Welcome back to this channel. So in today's class, I'll be taking you guys stoichiometry in Chem 101. Okay, so I'll be taking you guys stoichiometry in Chem 101, and this class video is divided into different categories. Okay, so the first part talk about mole. Okay, then the second category we talk about percentage composition, empirical formula, molecular formula, mole fraction. The next part we talk about limiting reactant or limiting reagent. Then the fourth part talk about percentage yield. Then while the last part talk about stoichiometry of solution, where we talk about molarity, molality, and normality, as well as calculations related to each part. Okay, so now let's start. Okay, so now what is mole? What is mole of a substance? Now the mole of a substance is that amount of that substance that contains 6.02 times 10 to the power 23 particles. Okay, so mole is that amount of substance that contains 6.02 times 10 to the power 23 particles. Okay, so I'll be fast with this part. Now, there are different formulas to calculate for the mole of a substance. Okay, don't forget that the mole of a substance is that amount of that substance that contains 6.02 times 10 to the power 23 particles. Okay, now there are different formulas in chemistry that you can use to calculate for mole. Okay, very first formula is that the number of mole of a substance usually equals to the given mass of that substance. Given mass of that substance divided by what? The molar mass. Okay, divided by the molar mass. Okay, then another formula to calculate for the mole is that another formula is mole of a substance is equals to what? Number of particles. Okay, number of particles. Okay, the particles here can be atom, ions, molecule. Okay, number of particles divided by 6.02 times 10 to the power 23. Okay, so there are different formulas to calculate for number of mole. Another formula is number of mole is equals to concentration, or you can say molarity times what? Times volume. Okay, so there are different formulas to calculate for mole. One formula is given mass divided by molar mass of that substance. The other formula to calculate for number of mole is number of particles divided by 6.02 times 10 to the power 23. Now remember, I told you guys that these particles here can be atoms, ions, or molecule. Now they can ask you to calculate for the number of ions in a particular substance. So they'll give you number of mole. They'll give you you know this one normally. So the formula you are going to use is this. Now, when they give you the given mass of that substance, they give you the molar mass, and they ask you to calculate for number of mole. Use this first formula. This second formula is used when they give you the number of particles. They can say number of ions, or number of atoms, or number of molecule. They'll give you this one. Just divide it by 6.02 times 10 to the power 23. We get your mole. Then another formula, another one is that they'll give you concentration, they'll give you volume. It's just for you to multiply it and you get your mole. So there are other formulas only for mole, but this can just help you to navigate through in stoichiometry. Okay, so in summary to this part is that the mole of a substance is that amount that contains, is that amount of that substance that contains 6.02 times 10 to the power 23 particles. Okay, so this is formula for number of mole. Okay, now before I enter limiting reagents, I will do mole and mole relationship. Okay, now let's move to this next part, which is percentage composition. Now don't forget that empirical formula, molecular formula, I've already done that in our previous class, so I will just do percentage composition and mole fraction. Now percentage composition. Okay, now what is percentage composition? Percentage composition of an element is the mass of that element in that particular in that particular compound. Okay, so percentage composition, the formula for percentage composition of a particular element is equals to, let me see, percentage composition is usually equals to the mass of the the mass of the element divided by the mass of the compound divided by mass of the compound times 100. Okay, so this is the formula you can use to calculate for the percentage composition of a particular element in a compound. Okay, so percentage composition of a particular element is percentage composition is usually equals to what? The mass of the element divided by what? The mass of the compound times 100. Okay, so this is formula you calculate for percentage composition. Now move to the next part. Okay, remember I told you guys that empirical formula and molecular formula, we have already done that. Okay, so in our previous class, I've already talked about that one. We have already done calculation regarding these two aspects. Okay, now let's move to mole ratio. Okay, please take note of this. Take note of this part. Percentage composition is equals to what? The mass of the element, or rather, you can say the molar mass. Okay, mass of the, okay, you can say the molar mass. Molar mass of the element divided by the molar mass of the compound. Okay, you can say molar mass of the compound. Okay, or yeah. So let's continue. Now let's continue with mole fraction. Okay. So now what do you understand by mole fraction? Now what is understand by mole fraction? Now the mole fraction of a particular substance is the ratio. Okay, the mole fraction. Let's say mole fraction. The mole fraction of a particular substance is the mole. Okay, it's very important. It's the mole of that substance. Is the ratio of the mole of that substance divided by the total mole of a mixture. I don't even understand. Now the mole ratio of a particular substance in a mixture is equals to what? Is value what? Is the ratio. Is the ratio of the mole of that substance all over the total all over the total mole of the component that makes up the mixture. Okay, so all over the mole of A plus the mole of B, then plus the mole of C. Okay, so this is very easy. This is mole ratio. Mole ratio is just the mole ratio. Let's say for example they ask us to look for the mole ratio of component C. For example, you just do it like this. You say okay, mole ratio of C is equals to what? The mole of C divided by what? The total mole of the component that makes up the mixture divided by total mole. That is the mole of A plus the mole of B, then plus the mole of what? The mole of C itself. Okay, that is total mole. Okay, now if they ask you to count, now what if they ask you for to calculate for the mole ratio um of um of B, for example, you say okay, the mole ratio of B is equals to what? The mole of B divided by what? The total mole of the mixture. Okay, that is total mole of the mixture, which is total mole of the mole of which the total mole of the mixture, the mole of the mole of A plus the mole of B, then plus the mole of C. Okay, so that is just it. Now let's say for example, let's say this is a mixture, okay, containing three substances. Okay, substance A, substance B, and substance C. Okay, so if they want to ask us, okay, we calculate. They say calculate for the mole ratio of B in this mixture. It's very easy. You say the mole ratio of B is equals to what? The mole of B itself. Okay, the mole of B is divided by the total mole of the mixture, which is total mole of A plus the mole of A plus mole of B plus mole of C. Okay, so this is mole ratio for you. Okay, now before I move to the next part, let's do few calculation under mole. Okay, now if you look at the very first question, I said how many moles of hydrogen gas are in 27 grams of hydrogen? So this is very easy. Remember, I gave you guys three formula to calculate for number of mole. The first formula is the number of mole is equals to given mass over what? Given mass divided by molar mass, right? Yes, okay. Then another formula I gave you guys that number of mole is equals to number of particles. Okay, number of particles. Remember, I told you guys that these particles can either be atom, molecule, and ions. Okay, number of particles divided by 6.02 times 10 to the power 23. The another formula I gave you guys again to calculate the number of mole is the number of mole is equals to concentration times volume. Okay, now if you look at this question, it said how many moles of hydrogen gas are in 27 grams of hydrogen. So if you look at this question, you find out that they give us the given mass of hydrogen, right? Yes, and they're asking us to look for what is the number of mole. We're not going to use this third formula because this question does not involve concentration and volume. Okay, then we're not going to use the second one because this question does not involve number of particles. Okay, so we're not going to use the third one. I mean the second one. Then we are going to use the first one because they gave us the given mass of hydrogen. Okay, so number of mole is equals to what? The given mass of hydrogen is 27, right? Yes. Now what is the molar mass of hydrogen gas? Molar mass of hydrogen gas is 2. So 27 going to 2 will give us the mole of give us the mole of hydrogen. Okay, so the sun going to give us 13.5 moles. So 13.5 moles. Okay, so that is how many moles of hydrogen gas are in 27 grams of hydrogen. So it's 13.5 moles. Now let's do the next question, which is question 2. They said, how many carbon atoms are in 0.0022 gram of carbon dioxide? Now, if you look at this question, you find that they said how many carbon atoms. Now, remember, I gave you guys three formulas on that number of mole, right? To calculate for mole, number of mole equals to given mass. Okay, given mass divided by molar mass, right? Yes. The other one is number of mole is equals to number of particles. Number of particles divided by 6.02 times 10^23. Then the last one I gave you guys is the number of moles equals to concentration times volume. Now, look at this one. They say how many carbon atoms. Now, you remember, I told you guys that this second one, this number of particles, the particles in there can stand for atoms, can stand for molecules, or can stand for ions. So, as you just see, how many carbon atoms are in 0.0022 gram of carbon dioxide, I just know that they are the formula we are going to use is this second formula. Okay, is this second formula we are going to use, because they're asking us to calculate for what the carbon atoms in carbon dioxide. Okay, they said how many carbon atoms are in 0.0022 gram of carbon dioxide. So we have to look for what number of particles. So therefore, remember, I told you guys the number of particles can mean number of atoms, can mean number of ions, or can mean number of molecules. So we are using this second formula. Okay, so therefore number, okay, we're looking for what? We're looking for um number of carbon atoms, right? So number of moles is equals to number of, we can say, since we are looking for carbon atoms, in the place of these particles you can put what? Number of carbon atoms, right? Number of carbon atoms divided by what? 6.02 times 10 to the power 23. Okay, so we're looking for number of carbon atoms. Okay, now, do we know the number of mole of carbon? No. So what are we going to do first? Remember, we are looking for this part, right? We are looking for number of carbon atoms. Yes, but we need to know the mole first. I don't even understand. Okay, we need to know the mole first. Before we now, remember this formula that I gave you guys, this first formula, number of mole is equals to giving mass over molar mass, and this other one, we can usually join them together. I don't know if you understand. We can usually join them together, okay? Yes, or we can just use one of them. We can use this one to get number of mole. Once you get number of mole, then we can use the number of mole and this one to get number of carbon atoms. Okay, so they said how many carbon atoms are in 0.0022 gram of carbon dioxide. Okay, yes, so we are looking for this part and we don't know the number of mole of carbon, so we are going to look for the number of mole of carbon first. Now, which formula are we going to use to look for number of mole of carbon first before we go back to this part? We can use this very first part, which is number of mole is equals to given mass over what? Molar mass, right? Yes. Now, where is given mass of carbon? Now, if you look at this question, they didn't give us the mass of carbon. What did they give us? They gave us the mass of carbon dioxide. I don't even understand. Had it been they gave us the mass of carbon, we would have just do it like this. Put the mass of carbon here divided by the molar mass of carbon, we get the number of mole. Then we take the number of mole here, we cross multiply, we get our number of carbon atoms. So what are we going to do? We need to look for we need to look for the mass of carbon inside carbon dioxide. Remember, this is carbon dioxide, right? Carbon dioxide made up of carbon and oxygen, right? So we need to first calculate the mass of. We need to first look for the mass of carbon inside carbon dioxide. Okay. Now, how are we going to do that? It's very easy. Okay. It's very easy to look for the mass of carbon inside carbon dioxide. It's very easy. You can just do it like this. You say, okay, molar mass of elements Okay, molar mass of element divided by molar mass of compound. Okay, divided by the molar mass of compound. Okay, then and then okay, I'm coming. Let me do it again. So look for the mass of carbon inside 0.022 gram of carbon dioxide. We're going to do something like this. The molar mass of elements, okay, divided by the mass number or molar or the molecular mass or the molar mass of compound, then times giving mass of compound. Okay, so we can use this formula to get the mass of carbon inside carbon dioxide, okay, which is very easy. So to get the mass of carbon inside carbon dioxide, we divide the molar mass of carbon divided by the molar mass of the compound, then times the given mass of the compound. Now, what is the molar mass of of the element here is what we are looking for. We want to look with the elements we're looking for is carbon, right? So now, what is the molar mass of carbon? The molar mass of carbon generally is what is 12, right? Divided by now, molar mass of compound, the compound is what? Carbon dioxide, right? Now, what is the molar mass of carbon dioxide? Molar mass of carbon dioxide is 44. Okay, CO2. Okay, remember, carbon is 12 plus oxygen is 16. 16 times 2 give us 32. So if we add everything, we have 44. Okay, so the molar mass of compound is 44, then times the given mass of the compound. Now, what is the given mass of the compound? Given mass of the compound is 0.0022 gram. So 0.0022 gram. Okay, so I'm giving mass, I'm coming giving mass of carbon, okay, or we can say, yeah, giving mass of carbon. So this is okay, mass of carbon, okay, mass of carbon. That's what we are looking for. Okay, mass of carbon. Okay, so if that in question like this, just to look for the mass of element in compound, just do it like this: molar mass of the element divided by molar mass of the compound, then times the given mass of the compound. Okay, so if we do everything, we get something like this. I'm coming 12 times 0.0022 divided by okay, let me do it first. Okay, if you multiply, we have 0.0264 divided by 44. So if we do it, the mass of carbon is 6 times 10 raised to power minus 4 gram. Okay, so we have gotten the mass of carbon inside carbon dioxide. So the mass of carbon, the mass of carbon inside this place is what 6 times 10 raised to power minus 4, right? So we go back to this place. Remember, we need to look for one. We need to remember. Don't forget that we're looking for the number of mole of carbon. Once the number of mole of carbon, we put it here. We cross multiply. We get the number of carbon atoms, right? So let's continue. Remember, number of mole is equal to what is the mass of carbon now is what? Is 6 times 10 raised to the power minus 4, right? Now the molar mass of carbon is 12. So if we divide it, what would be the mole? So let's divide it. So 6 times 10 raised to power minus 4. Okay, then I'm coming. Then divided by 12. So if we do everything, we have 5 times 10 to the minus 4. 5 times, I'm coming. 5 times 10 to the minus 5. Okay, so if we do everything, the number of mole is 5 times 10 to the minus 5. Okay, so this is the number of mole of carbon. Are we done yet? No, remember, we need to put this number of mole here to get number of carbon atoms. Okay, so let's continue. So the number of mole is what? Is 5 times 10 to the minus 5, right? Equals to number of carbon atoms which we are looking for divided by 6.02 times 10 to the 23, right? So if you cross multiply, S will be what? It will equals to what? If we multiply everything, cross multiply 5 times 10 to the minus 5 times 6.02 times 10 raised to the power 23. So our answer is the number of carbon atoms in 0.0022 gram of carbon dioxide is 3.01 times 10 raised to power 19. Okay, so it's very easy. Okay, now let me recapitulate the whole question again. Now if you look at the question, it said how many carbon atoms are in 0.0022 gram of carbon dioxide. Now remember, I gave you guys 3 formulas to calculate the number of mole, right? Now, in second formula, the second formula we are using the second formula, which is number of moles equals to number of carbon atoms divided by 6.02 times 10^23. Okay. Now, in the question, they didn't give us number of mole. Make you understand, they didn't give us number of mole. So we have to look for number of mole of carbon. Okay, which is n equals to given mass over molar mass. Okay, so that's just it. So we had to look for the given mass of carbon inside carbon dioxide. So when we get the mass, which is 5 times 10^-4, when we get the mass was 6 times 10^-4 gram, right? Yes. So we get the mass of carbon inside carbon dioxide, which was 6 times 10^-4. Then once we get when we get the mass, we divided the mass with the molar mass of carbon, we get the number of mole of carbon. Then we cross multiply, we get the number of carbon atoms. Okay. So that is just it. Okay. So that is just it. Now, now let's move to the next part, which is limiting reactant.